Modern physics and computer science are currently locked in a state of mathematical friction. We observe quantum mechanics operating as a system of smooth, continuous wave functions, but we try to simulate and study it using rigid computational architectures that can only process information in discrete steps. A theoretical proposition known as the frequency dimension codex has been published to bridge this specific divide. The core claim of the codex is absolute. It argues that all phenomena in the universe, whether classified as matter, energy, or information, are exclusively expressions and modulations of frequency. To operationalize this claim, the authors developed a central computational architecture they call the Gulf law. If physical reality can be natively computed through a single frequency-based equation, it solves the discrete continuous divide and rewrites our mathematical approach to universal simulation. Historically, physics has relied on a series of distinct foundational axioms to explain reality. We built our models on atomism, the concept of pure energy, and the fabric of spacetime. The Codex introduces the axiom of frequency, which argues that those previous historical foundations are not actually irreducible. This diagram illustrates the axiom of frequency operating as the central node. As the directional arrows show, older foundational models like atomism, spacetime, and energy are subsumed, categorized merely as emergent modulations of a singular frequency substrate. This framework also absorbs information theory, rendering digital bits and logic structures into pure frequency events. Discarding multiple historical axioms in favor of a single meta-axiom requires a mathematical engine capable of proving its universal validity. That brings us to the mechanics of the Gulf law formula. Let's look exactly at how the Gulf law equation is constructed. R equals Tf times Qc times the sum of Fi. R represents the computed reality event rate. QC stands for quantum context. This is a dimensionless operator that adjusts for specific system states, like probability amplitude. The sum of Fi is the total sum of all effective frequencies operating within a given system, measured in Hertz. The final variable, Tf, is the Foddy tempo unit, or FTU. This serves as the fundamental unit of time for the calculation. In an artificial digital environment, a system might use a standard CPU cycle for its FTU. But computing native physical reality requires an absolute, unchangeable physical foundation. Without a concrete empirical anchor for this time variable, the formula would remain a theoretical abstraction. The assignment of the FTU is the critical test of the entire framework. To achieve dimensional consistency, the FTU must be anchored to the absolute limits of physical reality. Physics already possesses this metric, Planck time, the smallest measurable time interval recognized by empirical science. Planck time is derived from the reduced Planck constant, the gravitational constant, and the speed of light. That calculation yields a precise numerical value, 5.39 times 10 to the negative 44 seconds. The framework issues a strict mandate here. For all physical reality computations, the FTU variable must perfectly equal Planck time. Locking the FTU to Planck time sets an unbreakable lower bound on reality computation. It theoretically ensures that no computed event generated by this law can be subdivided further by any physical experiment. We can test the viability of this framework in standard physics by running a strict dimensional analysis on the substituted formula. First, the FTU, functioning as Planck time, maps directly to a unit of seconds. Next, the summation of frequencies is measured in Hertz, which explicitly translates mathematically to inverse seconds. The quantum context remains a purely dimensionless unit, unaffected by time and frequency. When we execute the multiplication, seconds, multiplied by a dimensionless integer, multiplied by inverse seconds, the time units cancel out completely. This dimensional consistency yields a clean dimensionless value for R, proving the formula produces a valid fractional rate for reality events without dimensional mismatch. The source text provides a specific theoretical quantum event test case to observe the formula functioning in practice. First, we set the environmental variables. We assign the quantum context a value of 1, representing a completely pure quantum state. Next, we establish the total system frequency for this hypothetical event as 10 to the power of 43 Hertz. We then multiply this system frequency by the pure state context and finally by the Planck time constant. The calculation reveals a final computed result for this test event, r equals 0.0539. Mathematically, we interpret this as a fractional reality event rate occurring uniquely per Planck interval. Max Planck originally proved energy is quantized by frequency. The Gulf law directly mirrors that relation, but applies the quantization as a universal computational probability. Achieving dimensional consistency at the Planck scale means the computation can theoretically cascade upward from subatomic physics into macroscopic and digital systems. By isolating a singular computational tick, continuous wave-based quantum interactions can be mapped strictly as discrete, processable events. This flowchart diagrams the author's claim. By placing frequency at the origin point, it illustrates how emergent laws in biology, cosmology, and technology can branch entirely from one unified equation. The Gulf law is presented as a solution to the dimensional ambiguity between continuous physical systems and the discrete computational models used to study them. This framework proposes a highly disruptive architectural model, and it is currently undergoing open peer review. The authors have issued a specific challenge to the scientific community: attempt to find a physically measurable temporal unit smaller than Planck time in order to break the FTU anchor. If the FTU holds as an absolute mathematical lower bound, it establishes a new computational baseline for existence. Whether viewed as a philosophical meta-axiom or a functional computational substrate, the Gulf law demands a rigorous reevaluation of exactly how science computes reality.